What is time? To many of us, it seems straightforward, a simple sequence of moments ticking away as we go about our lives. But delve deeper, and you will find that time is a complex concept, enshrined in both philosophy and science. Historians trace the human understanding of time back to ancient civilizations, where the cyclical nature of time was closely linked to astronomical observations. The Babylonians, for instance, divided days into hours and minutes, laying the groundwork for our modern clocks. As we transition from ancient to modern thought, Aristotle offers insight into how we comprehend time. In his view, time is the measure of change. If nothing were to change, he argued, the concept of time would not exist. This led to a fundamental question: can time exist without change? Moving forward in history, we encounter Sir Isaac Newton, who revolutionized our understanding of time in the 17th century. He described time as absolute, flowing uniformly regardless of external factors. Newton famously stated, "Time flows in one direction, and there is nothing you can do to stop it." This notion dominated physics until the early 20th century. Enter Albert Einstein, whose theory of relativity would shatter the rigid concept of time as Newton saw it. Einstein proposed that time is not a constant but is relative, depending on speed and gravitational influence. According to his calculations, time slows down as one approaches the speed of light, leading to paradoxes that challenge our intuitions. For instance, consider the twin paradox, a thought experiment where one twin travels at near light speed while the other remains on Earth. When the traveling twin returns, they would find they have aged significantly less than their earthbound sibling. This is where we see the fusion of time with space, giving birth to the space-time continuum. Space-time is a four-dimensional construct where time and three-dimensional space intermingle. This concept reshapes our perception of the universe. Think about it: if time is bent and molded by mass and speed, are we victims of time, or do we exert some control over our experience of it? As we explore this further, we realize that time is not merely a ticking clock. It's an intricate dance between events, experiences, and perceptions. As we move through our day, we often feel like we are racing against time. But consider this: time can also seem to stand still during moments of great joy or profound grief. These emotional experiences alter our perception of time's passage. As we dissect the essence of time, we must also ponder its implications on our existence. Is our understanding of time rooted in the physical universe, or does it extend into the realm of consciousness? This chapter lays the foundation for our exploration ahead, where we will see how time influences everything from our biology to the cosmos itself. What awaits us as we uncover the scientific realities of time? Time feels different depending on the situation, doesn't it? Think about how a thrilling adventure can make hours feel like minutes, while a dull meeting stretches into eternity. This subjective nature of time perception is not just anecdotal, it is backed by cognitive science. Studies show that our brains process time differently based on various factors such as age, emotion, and attention. For example, a study by researchers at the University of California revealed that younger individuals tend to perceive time as passing more slowly compared to older individuals. This could explain why childhood summers feel endless, while adult life seems to fly by. Moreover, the emotion we experience significantly alters our perception of time. When we are engaged in an enjoyable activity, the brain releases dopamine, leading to distorted time perception. Conversely, stressful situations trigger the release of cortisol, which can speed up our sense of time passage. The concept of time as a psychological construct leads us to fascinating territory: flow state. When someone is fully immersed in an activity, whether it be painting, coding, or competitive sports, they can lose track of time altogether. Psychologist Mihai Csikszentmihalyi, who coined the term flow, found that individuals in this state experience great satisfaction and creativity. Consider the implications of this. If our perception of time can be so easily manipulated, what does that say about the lives we live? Are we masters over our own experiences? It prompts the question, is our time well spent? As we dive deeper, we discover the intricacies of societal constructs around time. Every culture has its own belief systems and practices regarding time. In Western societies, time is often viewed linearly, with a focus on efficiency and productivity. In contrast, many indigenous cultures see time as cyclical, emphasizing the importance of seasons and natural rhythms. The ramifications of these differing perceptions are profound. In our fast-paced world, we often overlook the connectedness of events and the cyclical nature of time. This fragmented view of time can lead to stress and anxiety. The pressure to constantly produce and perform in our society begs a critical reassessment of how we value and perceive time. As we continue our exploration of time, the next chapter delves into the biological clock within us, the circadian rhythms that govern our sleep, mood, and overall health. What happens when we are out of sync with our biological time, and how does it affect our lives? Have you ever wondered why you naturally feel awake during the day and sleepy at night? This phenomenon can be attributed to our circadian rhythms, internal biological clocks that operate on a roughly 24-hour cycle. These rhythms influence sleep patterns, hormone release, and body temperature, playing a crucial role in our overall health. The term circadian comes from Latin roots meaning about a day, and research shows that these rhythms are not just limited to humans. All living organisms, from plants to animals, are governed by circadian rhythms. In fact, plants exhibit behaviors like opening and closing flowers based on sunlight, demonstrating a remarkable connection to the daily cycle. But what happens when these rhythms are disrupted? Modern life, with its artificial lighting, shift work, and incessant screens, has drastically altered our relationship with natural time. Studies indicate that disruptions can lead to sleep disorders, metabolic issues, and even mood disorders like depression. The National Sleep Foundation suggests that approximately 50 to 70 million adults in the U.S. have a sleep disorder, highlighting the crucial nature of aligning with our biological clocks. Additionally, researchers have found a link between circadian rhythms and health. It has been established that individuals who maintain a regular sleep schedule have better cognitive function and emotional regulation. In contrast, circadian misalignment, such as that experienced by night shift workers, can lead to serious health complications, including heart disease, obesity, and diabetes. Understanding circadian rhythms offers a glimpse into how profoundly time affects our biology. The famed sleep researcher Matthew Walker asserts that when we sleep better, we perform better. So, what can we do to better align with our biological time? Simple changes like reducing screen time before bed, maintaining consistent sleep schedules, and maximizing exposure to natural light can significantly improve our well-being. However, in a world that constantly demands our attention, adapting to our biological clock is no easy feat. As we progress, we transition from the microcosm of our biology to the grander scales of time in the universe. In the next chapter, we will explore the measurement of time throughout history and the profound tools humanity has developed to quantify this elusive concept. How have our methods for measuring time evolved over the centuries? The quest to measure time dates back thousands of years, illuminating humanity's desire to understand and conquer this elusive dimension. Ancient civilizations devised various methods to track the passage of time, from sundials to water clocks. Each innovation marked a monumental leap in human understanding. The sundial was one of our earliest instruments, employing the sun's position to cast a shadow on a marked surface. This method was relatively straightforward, but it was limited to daylight hours. The Egyptians later innovated with water clocks, known as clepsydra, that measured time using the controlled flow of water, allowing them to measure time during both day and night. As we leap forward to the medieval era, mechanical clocks began to emerge. By the late 13th century, these devices transformed people's relationship with time. However, it was not until the 17th century that the pendulum clock was invented by Christian Huygens, significantly improving accuracy. This invention prompted questions about how precise measurements of time could influence navigation and exploration. The development of accurate timekeeping was indispensable for maritime navigation, leading to the quest for the prime meridian and the establishment of time zones. The British scientist John Harrison invented the marine chronometer in the 18th century, enabling sailors to determine their longitude accurately. Fast forward to the 20th century, where advances in technology delivered even greater precision. Atomic clocks operate based on the vibrations of atoms, significantly enhancing accuracy and reliability. These clocks are now the standard for global timekeeping. The International System of Units defines the second as the duration of 9,192,631,770 cycles of microwave radiation corresponding to the transition between two hyperfine levels of the ground state of cesium-133 atoms. This is a remarkable leap from sundials to atomic standards. Yet, the question of time's measurement continues to evolve. With the advent of quantum physics, scientists are grappling with the essence of time itself and whether it's a fundamental aspect of the universe or an emergent property. This ongoing debate has far-reaching implications. As we consider the tools developed to measure time, we must also ponder the philosophical implications of these advancements. How do our methods of measuring time shape our culture, our work patterns, and, indeed, our very lives? In the next chapter, we will explore the nonlinear nature of time, how time can stretch and bend, revealing more profound insights into the fabric of reality. What if time is not as linear as we perceive? This notion might seem counterintuitive, but various scientific theories propose that time can be nonlinear, stretching and compressing in ways that challenge our understanding. First, we must restate Einstein's theory of relativity, which posits that time can be affected by gravity and speed. For example, the closer you are to a massive object like a planet, the slower time moves for you compared to someone far from that object. This has been experimentally verified through incredibly accurate atomic clocks placed at different altitudes. Clocks on satellites, orbiting Earth at high speeds, exhibit time dilation as predicted by relativity. These findings have profound implications, suggesting that two observers in different gravitational fields could experience time differently. The concept of nonlinear time also extends into theoretical physics with ideas surrounding the fabric of spacetime. Stephen Hawking proposed that the universe has a beginning and might even have an end, leading to intriguing questions about what happens to time in these scenarios. When considering black holes, for instance, they warp time, and theories suggest that crossing a black hole's event horizon could lead to alternate timelines or even time travel. But let's not limit ourselves to the scientific realm. The philosophy surrounding nonlinear time can be traced to various cultural beliefs and practices. In many Eastern philosophies, time is viewed cyclically. For instance, Hinduism speaks of yugas, a cyclical concept of time where universes are born, exist, and eventually dissolve. This radically different view of time has shaped cultures and spiritual practices for millennia. Furthermore, the literary world has embraced the nonlinear narrative structure. Works like Slaughterhouse-Five by Kurt Vonnegut depict time as non-sequential, reflecting the complexity of human experience. In these narratives, the fluidity of time allows characters to navigate past, present, and future simultaneously. As we start connecting the dots, the impact of nonlinear time transcends theoretical frameworks. It invites us to reconsider crucial areas of our lives, our memories, emotions, and relationships. What if our memories are not fixed in time but are instead malleable, changing based on our current experiences? This leads us into deeper philosophical questions about fate, free will, and the choices we make. If time is nonlinear and fluid, how do our choices resonate through time? As we conclude this chapter, we stand on the precipice of profound understanding and exploration. In the next chapter, we will navigate the connection between time and the cosmos, exploring how the universe itself operates within the vast expanse of time. Imagine a world where you could step into a machine and travel to the past, witnessing historical events firsthand, or leaping into the future to see how humanity evolves. The concept of time travel has long captivated both scientists and the general public alike. But is it merely a figment of our collective imagination, or does physics actually allow for its possibility? To delve into this fascinating topic, we need to explore the scientific theories that suggest time travel isn't just a fantasy but a conceivable reality. First, let's discuss the foundational principles of relativity that Einstein introduced in the early 20th century. According to his theory of special relativity, time is not a fixed entity but can stretch and compress depending on speed and gravity. For instance, if you were to travel at near light speed, time would slow down for you relative to someone who remained stationary on Earth. This effect, known as time dilation, demonstrates that time behaves differently under certain conditions, creating a conceptual loophole for time travel. Now, let's consider black holes. These enigmatic celestial objects have gravitational pulls so strong that they warp space-time itself. Theoretical physicists, like Kip Thorne, suggest that if you could find a way to navigate the environment around a black hole, you might create a passage through time. Would this mean that entering a black hole could catapult you to another time? The concept of wormholes, a sort of shortcut through space-time, offers another tantalizing hint at time travel. If these structures exist, created by immense gravitational forces, they could theoretically connect distant points in time and space. This leads us to the controversial notion of parallel universes or the multiverse theory. What if each time travel event creates a new timeline, allowing one to exist without altering one's original past? This theory posits that every decision branches off into alternate realities, making time travel a more complex and multifaceted concept. However, scientific barriers remain. The energy requirements for bending spacetime or creating stable wormholes are far beyond our current capabilities. Additionally, ethical dilemmas arise. If you could alter the past, should you? Would fixing a personal mistake lead to unforeseen consequences, creating a ripple effect through time? The implications are profound. As we ponder these questions, it's essential to recognize a point made by physicist Brian Greene: time travel is a human obsession. It's more than just scientific inquiry. It reflects our desires and fears about mortality and choice. In films, literature, and even video games, time travel serves as a narrative device that explores our innermost questions. Will we ever transcend the linear passage of time? Only time will tell. As we close this chapter, consider what your life might be like if you could revisit moments, a chance to change or relive your happiest days. Would you take that leap? As we venture forward, the next chapter will unveil how our understanding of time influences the fabric of the universe itself. The passage of time is not just a scientific concept, it profoundly impacts our psychology, emotions, and behaviors. Understanding how we perceive and interact with time can shed light on our decision-making processes and overall mental health. Many psychologists believe that human perception of time is influenced by a multitude of factors, including age, culture, and even individual experiences. Consider the perspective of a child versus that of an adult. For children, time seems to stretch forever. Days feel like weeks, and summers are endless. In contrast, as we age, time appears to accelerate, weeks turn into months, and years fly by. Research from the University of Massachusetts suggests that the perceived speed of time changes with emotional intensity, a concept described as time flies when you're having fun. But in moments of fear or sadness, time can feel stretched and distorted. One remarkable study conducted by psychologists at the University of Southern California involved participants recalling moments of joy versus moments of distress. The findings revealed that joyful memories were perceived as long-lasting, while sad memories felt fleeting. This phenomenon not only underscores our emotional connection to time but also suggests that creating more positive experiences can help us appreciate life more fully. Cultural differences in time perception also play a significant role. Western societies tend to value punctuality and linearity. Time is seen as a commodity to be spent wisely. Conversely, many indigenous cultures view time as cyclical, closely intertwined with nature and community. This divergence affects everything from work ethics to personal relationships, showcasing how our environment shapes our understanding of time. Additionally, our fast-paced world, with constant notifications, social media, and the pressure to be productive, has led to what some are calling time poverty. A study by the American Psychological Association indicates that over 60% of people feel they never have enough time. This stress can lead to anxiety and a decline in well-being. Mindfulness practices, gaining popularity in recent years, encourage individuals to embrace the present moment and slow down, offering a potential remedy to our frenzied perceptions of time. Visual arts and literature often reflect our society's relationship with time. For instance, the existential musings of writers like Virginia Woolf and philosophers such as Henri Bergson provide profound insights into the emotional weight of time. They challenge us to consider how our memories shape our realities, urging us to grapple with the inevitable passage of time. As we draw this chapter to a close, remember, the way we perceive time influences our lives significantly. Cherish those moments of joy, and recognize the weight of your experiences, for it is through these memories that we construct our own understanding of time. Next, we will journey into how the concept of time has shaped our societies throughout history. From the ancients who observed celestial movements to modern-day applications of atomic clocks, the measurement and understanding of time have evolved dramatically. Time has been an essential aspect of human civilization, influencing social structures, economies, and cultures. Let's start with the ancient Egyptians, who created one of the earliest known calendars based on the lunar and solar cycles. Their innovative timekeeping methods were not just practical, they were woven into the fabric of their spirituality and daily life. The Egyptians used sundials and water clocks, demonstrating an early recognition of time's importance in organizing agricultural cycles and religious festivals. Fast forward to the Greeks, whose philosophers deeply contemplated the nature of time. Aristotle's ideas contrasted with those of Plato, leading to rich discussions that laid the groundwork for our modern understanding. The Greek contribution to timekeeping culminated in the development of mechanical clocks in the Middle Ages, revolutionizing how people perceived time and its passing. By the Renaissance, time had become a major subject of scientific inquiry. Galileo famously studied pendulum motion, which contributed to more accurate timekeeping devices. This was crucial for navigation. Sailors depended on precise timekeeping to determine their longitude at sea. The impact of time on society was profound, allowing for global trade to flourish and leading to the age of exploration. The Industrial Revolution marked a dramatic leap in time's significance. Factories required synchronization, leading to the creation of standardized time zones. Sir Sandford Fleming proposed the global time zone system we use today, a decision that fundamentally altered our relationship with time. The advent of electricity further extended working hours, making time even more crucial in daily life. In the modern world, technology has transformed our relationship with time yet again. With the rise of the internet and smartphones, we are constantly connected, altering our perception and value of time. Productivity hacks abound, promising to help us take back control over our time. However, as we've seen in previous chapters, this creates a duality where our modern conveniences can also lead to stress and anxiety. As we reflect on the history of time, consider how it has shaped human experience and societal evolution. What does the future hold? The next chapter will explore how our understanding of time might change as science continues to advance, revealing new dimensions of this elusive concept. As we stand on the cusp of new technologies like quantum computing and artificial intelligence, what does the future hold for our understanding of time? The evolution of our relationship with time is poised to take a transformative turn, one that may blend science fiction with reality. One of the most exciting prospects comes from quantum mechanics. Researchers at institutions like MIT and Caltech are exploring how quantum entanglement might connect distant events in time. This could lead to breakthroughs in understanding how time truly functions at a fundamental level. Imagine a world where instantaneous communication transcends the boundaries of time itself. Moreover, advancements in neuroscience suggest that our brain's perception of time may also evolve. Neurobiologists are studying how brain structures like the suprachiasmatic nucleus, which regulates circadian rhythms, might be influenced by technology, environmental changes, and societal structures. As our lifestyles evolve, so might our biological clocks, leading to new understandings of how we relate to time. Artificial intelligence is already reshaping how we manage time with algorithms that optimize our schedules and increase productivity. However, this leads to ethical questions. Will AI dictate our perception of time, potentially causing a detachment from our own experiences? Might we lose our ability to appreciate the simple moments, those fleeting interactions that give life meaning? The concept of time may also face philosophical challenges in the coming years. As scientists explore multiverse theories and time travel possibilities, we may need to redefine our very understanding of existence itself. The implications of these discoveries will extend beyond science and into ethics, as we grapple with what it means to live in a reality where time might not be as linear as we once thought. As we peer into the horizon of time, it's clear that our journey has just begun. What remains timeless, however, is the human experience, the memories we create, the moments we cherish, and the stories that shape who we are. As we continue on this exploration, remember that while time is a powerful force, our capacity to create meaning within it is a testament to the human spirit. As we approach the final chapter, reflect on the many ways time has illuminated and challenged our existence, and what it means to embrace its mysteries. Time is more than just a measurement or a scientific concept. It serves as a canvas for our thoughts, emotions, and philosophies. As we conclude our exploration, let's delve into the deeper implications of time on our understanding of existence and the human condition. Throughout history, thinkers like Immanuel Kant and Martin Heidegger have grappled with the nature of time, proposing that it is not merely an external construct, but a fundamental aspect of human consciousness. Kant argued that time is an a priori intuition, shaping human experience, while Heidegger emphasized the relationship between time and being, how our awareness of mortality gives depth to our lives. In contemporary philosophy, discussions around time revolve around concepts like time perception, memory, and existence. Theories of presentism and eternalism engage with the question of whether only the present exists or if past and future events are equally real. This debate challenges us to consider how our understanding of time shapes our understanding of reality. Moreover, time influences our moral and ethical decision-making. As we contemplate our actions, we reflect on past experiences while considering the potential consequences for the future. This temporal awareness fosters a sense of responsibility and can drive societal progress. The importance of historical legacy and future sustainability is a testament to how time shapes our values. In the realm of art and literature, time serves as a potent theme. Writers like Proust explore memory and the passage of time, indicating that our identities are intertwined with our experiences. Similarly, visual artists create works that challenge our perception of time through fleeting moments captured on canvas. The artistic reflections of time encourage us to pause and appreciate the beauty in our transience. As we conclude this exploration of time, consider the words of philosopher Henri Bergson: the more we analyze time, the more it eludes us. Time, in its essence, remains one of life's greatest mysteries, urging us to ponder its significance while living in the present moment. The journey through time invites us to reflect on our paths, recognize the interconnectedness of our lives, and motivate us to cherish each moment. In a world that often rushes forward, let this exploration remind us to pause, reflect, and truly live in the time that is ours. May we continue to seek understanding and meaning in our relationship with time, forever curious about the wonders it holds. Thank you for joining us on this profound journey through the science and philosophy of time. Imagine a world where time bends and warps, influenced by the very fabric of space itself. This isn't a fantasy, it's the reality we inhabit according to Einstein's theory of relativity. Time is not an absolute constant but a variable that shifts depending on your position and speed. When we think about time, we often imagine a straight line stretching from past to future. However, in the realm of physics, especially when considering objects moving at the speed of light, time can behave quite differently. This chapter will explore the fascinating implications of time relativity, revealing how astronauts aboard the International Space Station experience time differently than those of us on Earth. The faster you move through space, the slower you move through time, a phenomenon known as time dilation. This was famously demonstrated by the Haffel-Keating experiment in 1971, where atomic clocks flown around the world were compared against those on the ground, illustrating that the clocks in motion ticked slightly slower. We'll delve into the concept of simultaneity, where two observers moving relative to each other may disagree on whether events occurred simultaneously. By examining these concepts, we can understand how time is more like a river with eddies and currents rather than a rigid highway. But what does this mean for our understanding of reality? Can time travel become more than just a theoretical concept? As we look into these questions, we'll uncover stories from physicists who dedicated their lives to unraveling the complexities of time and the universe itself. Prepare yourself for a journey that bends the very perception of reality. Time is not just a scientific construct, it's deeply woven into the cultural fabric of societies around the world. Different cultures have unique perceptions of time that dramatically influence their daily life, traditions, and rituals. In Western cultures, time is often viewed linearly, as a resource that can be managed and allocated, hence expressions like time is money. This chapter will examine how indigenous cultures, such as those of the Native American tribes, perceive time as cyclical, a concept much more in tune with the natural rhythms of the earth. We will explore the fascinating concept of polychronic versus monochronic time, where cultures that operate on polychronic time, like many Latin American and Middle Eastern cultures, view time as more fluid, emphasizing relationships over strict adherence to schedules. Through anecdotes and interviews, we will bring to life the stark contrasts between punctuality and fluidity, revealing how these cultural markers shape not only lifestyles but global interactions. What happens when these varying cultural perspectives collide? We'll discuss how globalization is merging these views and altering how societies experience time, from Tokyo's fast-paced lifestyle to the languid days of rural villages in India. This chapter will open your eyes to the profound impact that our understanding of time has on the fabric of human relationships and community dynamics. What if time, at its most fundamental level, behaves according to the strange rules of quantum mechanics? In the world of quantum physics, time takes on a mysterious quality, shifting our traditional notions of past, present, and future. This chapter delves into the interplay between time and the quantum world, exploring concepts like entanglement and superposition, where particles can exist in multiple states simultaneously, challenging our linear understanding of time. How does one moment relate to another, and can they exist independently of our perception? We will discuss intriguing experiments that illustrate time's elusive nature, such as the delayed choice quantum eraser experiment, which raises questions about the arrow of time. As we explore the work of pioneering physicists like Carlo Rovelli and his notion of relational time, we'll reveal how time may not be a fundamental ingredient of the universe but rather a construct arising from the relationships between events. Imagine a reality where the past, present, and future are not distinctly separate but interconnected in a fabric of existence. Could this understanding lead us toward a future where we can manipulate time itself? Join us as we unravel this quantum enigma, suggesting that the key to understanding time may lie at the intersection of physics, philosophy, and consciousness. What if the seconds ticking away on your clock meant something entirely different to someone traveling at the speed of light? Albert Einstein's theory of relativity reshaped our understanding of the universe and the nature of time itself. Imagine a scenario where two twin brothers, one stays on Earth while the other journeys into space at near light speed. When the traveling twin returns, he finds that his brother has aged significantly more than he has. This thought experiment, known as the twin paradox, illustrates the bizarre and fascinating nature of time as described by Einstein. Einstein proposed that time is not a constant, but rather a flexible dimension interwoven with the fabric of space. The faster an object moves, the more time slows down for it relative to a stationary observer. This has profound implications for our understanding of reality, suggesting that time is less a linear progression and more a malleable continuum. To further grasp this concept, let's delve into the scientific foundation of relativity. In 1905, Einstein published his special theory of relativity, which posited that the laws of physics are the same for all observers, regardless of their relative motion. A key postulate of his theory is that the speed of light in a vacuum is constant and will always be approximately 299,792 kilometers per second, or about 186,282 miles per second, for any observer, regardless of their state of motion. This constancy leads to the conclusion that time and space are not separate entities but are linked together, creating a four-dimensional space-time framework. Consider a practical manifestation of this theory: GPS satellites. These satellites orbit the Earth and are affected by both their velocity and the gravitational pull of the Earth, which alters their perception of time. Engineers must correct for these relativistic effects, otherwise, our GPS systems would become inaccurate by about 10 kilometers each day. This real-world application evidences how relativity is not just theoretical, but a practical aspect of our daily lives. Now, let's weave in the philosophical implications of relativity. If time is malleable, what does that mean for free will and determinism? Are our paths through time predetermined, or do we navigate through a labyrinth of potential timelines? Philosophers argue about these questions, debating the nature of existence itself. In essence, the relativity of time invites us to reconsider our understanding of reality. It challenges us to see time as a dynamic, rather than a static, aspect of the universe. As we proceed, we will explore how these concepts manifest in other dimensions of existence. What lies on the horizon of our understanding of time? It's fascinating to consider how different cultures perceive time. While the Western world often views time as linear, many Eastern cultures see it as cyclical. This difference shapes how societies function, how individuals prioritize their lives, and even how they interact with one another. In this chapter, we will journey through various cultures and reveal how their unique perspectives on time influence their customs, traditions, and worldview. Take, for instance, the concept of monochronic and polychronic time. Monochronic cultures, such as those in the United States and Germany, emphasize punctuality and the importance of scheduling. Time is viewed as a commodity, something that can be spent, wasted, or saved. In contrast, polychronic cultures, like those in Latin America and many Arab countries, see time as a more fluid concept. Relationships and interactions take precedence over strict adherence to schedules. An emblematic example can be found in the unique celebration of the New Year across diverse cultures. In the United States, we usher in the New Year on January 1st, often with midnight countdowns, fireworks, and celebrations that embody the concept of fresh beginnings. However, in the Chinese culture, the Lunar New Year occurs on a different date entirely, celebrated with family gatherings, feasts, and rituals that signal renewal and hope, a cyclical perspective that harmonizes with the agricultural calendar. Moving to East Africa, let's explore the Ubuntu philosophy, which prioritizes community and interconnectedness over individual achievement. In cultures that embrace Ubuntu, the timing of events may be less structured, valuing the presence and participation of individuals over the clock. This perspective fosters a sense of unity, highlighting how time is often not just about hours and minutes, but about shared experiences. Moreover, indigenous cultures often have rich narratives tied to their perception of time. The Australian Aboriginal people, for instance, have a concept often referred to as the dream time, which encompasses the creation of the world and serves as a spiritual framework through which they understand their past, present, and future. This sense of time is not confined to linear progress but is fluid, intertwining myth, memory, and identity. As we reflect on these diverse perspectives, it becomes apparent that time is not merely a ticking clock but a deeply rooted cultural construct. This awareness can transform how we engage with others from different backgrounds, fostering greater empathy and understanding. So, as we venture forth, think about how these varying views on time might influence our global society. Could there be a time when our views converge? As we delve deeper into the mysteries of time, we encounter one of the most perplexing realms of modern physics, quantum mechanics. In the quantum world, the laws of time operate in ways that challenge our traditional understanding. Picture this: particles can exist in multiple states at once, entangled over vast distances, seemingly ignoring the constraints of time as we know it. This chapter will explore the complex relationship between time and quantum theory, revealing how this intersection has the potential to revolutionize our understanding of reality. First, let's consider the concept of superposition. In quantum mechanics, particles like electrons can exist in a state of superposition, where they are simultaneously in multiple states or locations until they are observed. This challenges our classical perception of time as a straightforward progression from past to future. Instead, time in the quantum realm may not adhere to a linear narrative at all, hinting at a more intricate weave of possibilities. Furthermore, we must address quantum entanglement, where two particles become intertwined in such a way that the state of one instantaneously influences the state of another, regardless of the distance separating them. This phenomenon suggests that information can be transmitted faster than the speed of light, raising questions about causality and the flow of time itself. Does this mean time is not as absolute as we once thought? To further illuminate our understanding, let's examine the work of physicist Carlo Rovelli, who proposed the idea that time is an emergent property rather than a fundamental aspect of reality. In his book, The Order of Time, Rovelli argues that at the quantum level, the events that occur are not measured against a fixed timeline, but rather occur in relation to interactions between particles. This perspective invites us to consider the possibility that our perception of time is constructed from a series of interconnected events, leading us to question the very nature of existence. Moreover, the implications of a quantum understanding of time stretch far beyond physics. In the realm of philosophy, thinkers like Julian Barber have proposed that time might not exist at all. Instead, he suggests that what we perceive as time is merely a collection of nows, each moment uniquely distinct yet interconnected. This raises profound questions. If time is an illusion, then what does it mean for our memories, our experiences, and our very being? As we navigate these intricate quantum landscapes, we find ourselves at the edge of a profound transformation in our understanding of time. Could it be that the traditional narrative of past, present, and future is merely a construct of human perception? As we shift our focus towards the stars and beyond, these quantum insights beckon us to reconsider the reality of time itself. As we dive deeper into the concept of time, one cannot ignore the profound impact technology has on our perception and measurement of time. From the invention of sundials to atomic clocks, our relationship with time has evolved significantly. In ancient civilizations, time was often measured by the position of celestial bodies. The Egyptians, for example, utilized sundials, which also helped in farming by indicating the best time for planting crops. With the advent of mechanical clocks in the Middle Ages, a significant shift occurred. Time became a commodity, regulated by society. Those who controlled time, controlled productivity. Fast forward to the 20th century, and the introduction of electronic clocks changed everything. But it wasn't until the invention of the atomic clock in the 1950s that we truly grasped the meaning of precise time measurement. An atomic clock uses the vibrations of atoms to maintain accuracy to within a second over millions of years. This precision is essential for modern technologies, GPS, satellite communications, and even the functioning of the Internet rely on synchronized time. However, this synchronization raises interesting questions. How does our reliance on technology for measuring time alter our perception of it? As people become increasingly dependent on clock time, our natural rhythms may be disrupted, leading to stress and anxiety. Consider a study from the University of California, which found that the average person checks their phone over 150 times daily, often to check the time. This constant checking creates a fractured perception of time, causing individuals to feel rushed even when they are not. What about the future? As we advance further into the digital age, is it possible we may find a way to experience time differently? Can technology help us free ourselves from the chains of clock time? As we explore these questions, we will uncover how technology shapes our understanding of time and opens up new possibilities for its measurement. In the next chapter, we will further examine the biological implications of our time-centric culture. Imagine waking up one day and realizing that the time on your clock no longer matches the world outside. Time zones, a concept developed to manage the chaos of local time, have transformed how we perceive and interact with the world around us. Before the establishment of standardized time zones in the late 19th century, local solar time ruled in every town and city. Trains, however, changed everything. As rail networks expanded, so did the need for a uniform time framework. In 1884, the International Meridian Conference established the system of 24 time zones, each 1 hour apart. This decision fundamentally changed our perception and coordination of time across the globe. Yet, with the positive came the negative. Time zones can create confusion, impact international business, and even disrupt personal relationships. Research indicates that about 60% of people struggle with scheduling meetings that involve participants from different time zones. This disarray not only affects productivity but can also create frustrations that hinder cross-border collaboration. Furthermore, the psychological effects of time zones extend beyond work. Imagine trying to call a loved one only to learn it's the middle of the night in their location. The concept of jet lag exemplifies the challenges a divided world presents. Our internal clocks become misaligned with our surroundings. Studies show that it takes about a day per time zone crossed to adjust fully. But what does this mean in our increasingly connected world? As travel becomes easier and more frequent, addressing the impact of time zones on our health, relationships, and social interactions is critical. As we continue to navigate a world where every second counts, can we find a way to harmonize our internal clocks with the external chaos of time zones? In the next chapter, we will explore the fascinating intersection of time and culture. What if I told you that not everyone experiences time in the same way? Across cultures, the interpretation and significance of time vary dramatically, shaping lives, traditions, and societal structures. In the Western world, time is often viewed linearly, past, present, future, as a finite resource that must be managed efficiently. This perception drives punctuality and ownership over one's time. In contrast, many indigenous cultures embrace a cyclical view of time, where past, present, and future coexist. For example, the Maori of New Zealand regard time as interconnected with nature, where seasons and cycles dictate daily life. In their worldview, time is not something to be conquered but rather to be respected and felt. A fascinating study highlighted how this cyclical perception influences social dynamics in indigenous communities, fostering relationships and community bonds over rigid scheduling. Furthermore, countries such as Japan and Germany exemplify the Western narrative of efficiency, often enforcing strict adherence to time. But this cultural obsession with time can lead to stress and burnout. In countries with a more relaxed approach to time, like Brazil and Spain, life seems to flow differently. Here, meals and social gatherings can stretch for hours, with time seen as an opportunity to connect rather than a constraint. This cultural divergence begs the question, is it time to reconsider our relationship with time? Can we learn from cultures that embrace a more fluid approach? In our ever-globalizing world, understanding these cultural perceptions might just hold the key to healthier, more fulfilling lives. As we move into our next chapter, we will analyze how time and perception intertwine in our fast-paced, modern society. Imagine a world where time flows differently depending on your location. Welcome to the phenomenon of time dilation. It's a mind-bending concept rooted in Einstein's theory of relativity. According to this theory, time isn't an absolute constant, rather, it is affected by speed and gravitational fields. Think of the twin paradox. If one twin travels to space at near light speed while the other remains on Earth, upon their reunion, the traveling twin will be younger than their Earth-bound sibling. This idea was not just theoretical, it has practical applications. For instance, GPS satellites orbit the Earth at high speeds and experience less gravity than we do on the surface. If we didn't account for time dilation, GPS systems would drift significantly, leading to navigation errors of about 10 kilometers every day. Real-world experiments have confirmed time dilation. In 1971, physicists Haffel and Keating flew atomic clocks around the world. Upon their return, the clocks showed a measurable difference compared to stationary clocks on Earth. This was a revelation that proved time can be stretched or compressed. As we push the boundaries of physics, researchers are exploring extreme conditions, like near black holes, where time dramatically slows down. For instance, scientists at the Event Horizon Telescope captured the first image of a black hole at the center of our galaxy, Sagittarius A star. The gravity near it is so intense that time behaves unpredictably. The implications of time dilation extend beyond science fiction. They raise poignant questions about life, aging, and the universe. As we journey deeper into our understanding of the cosmos, we may even look to harness these phenomena for space travel. Can we one day traverse the universe and return to find centuries have passed? Understanding time in this way alters our perspective, not just of the universe but of our existence within it. As we unravel the mysteries of time dilation, we are confronted with the profound nature of reality itself. Will we one day find ways to manipulate time itself? Time has not just shaped the universe but has also been a crucial force in the evolution of life on Earth. From the dawn of single-celled organisms to the complex web of life we see today, understanding the timeline of evolution is key to grasping how life adapts and thrives. The fossil record reveals a timeline stretching over 3.5 billion years. Imagine the world when the first cells emerged, an environment teeming with microbial life, battling for survival. Over millions of years, evolution operated like an intricate clockwork mechanism, refining organisms through natural selection. Consider the story of the peppered moth in England during the Industrial Revolution. As pollution darkened the trees, the once white moths became more visible to predators, while the darker moths thrived and multiplied. This rapid evolution showcases how time influences survival, adapting species to their environments. The concept of evolutionary time can be expressed through the so-called evolutionary clock, which estimates how long it has taken for a species to evolve from a common ancestor. Scientists utilize molecular data to trace back lineages, revealing timelines that can span millions of years. Moreover, the interplay between time and evolution also poses interesting questions about extinction. The Cretaceous-Paleogene extinction event, which wiped out the dinosaurs 66 million years ago, illustrates how catastrophic changes can drastically alter the course of life. As a result, modern mammals evolved in the absence of their prehistoric competitors. Today, we continue to witness evolution in action. With the rise of antibiotic resistance in bacteria, we see how rapid changes in our environment can outpace traditional evolutionary timelines. Understanding these dynamics is crucial, especially as we confront climate change and habitat loss. How will future species adapt? Will they evolve to withstand harsh conditions that we cannot even imagine? The story of evolution is still being written, and time remains a relentless author in this saga. Each passing moment shapes life's intricate dance through history, prompting us to reflect on our place in the vast timeline of existence. Time is woven into the very fabric of our societies. It governs our routines, influences our cultures, and shapes our social structures. From the moment we wake up to the time we go to bed, our lives are punctuated by a series of rituals that reflect our understanding and perception of time. The ancient Egyptians were among the first to establish a structured approach to time. They relied on the movements of the sun and stars to create a calendar that would dictate agricultural cycles. By marking the annual flooding of the Nile, they ensured their crops flourished. Fast forward to today, and we find ourselves caught in a whirlwind of schedules and appointments. The relentless ticking of the clock is often a source of stress in our fast-paced world. Studies show that time pressure can lead to anxiety and reduced productivity. But why do we allow ourselves to become so enslaved by time? In many cultures, time is not viewed as a linear progression but rather as a cyclical phenomenon. Indigenous cultures often celebrate time through rituals that honor seasonal changes and ancestral connections. These perspectives can offer valuable insights into sustainable living. Rituals surrounding time, such as New Year celebrations, highlight the human desire to mark the passage of time with meaning. Each culture has its unique traditions, for example, the Japanese practice of hanami, which celebrates the cherry blossom season, embraces change and transient beauty. Interestingly, the concept of work and leisure time has evolved. From the Industrial Revolution to modern telecommuting, our relationship with time continues to shift. Today, we face the challenge of finding balance, balancing work with well-being, productivity with relaxation. In an age where technology dominates, the lines blur between our professional and personal lives. The advent of the smartphone has made every moment accessible, yet advocates for digital detox remind us of the need to reclaim our time. As we consider the social implications of time, we must ask ourselves, how do our daily routines reflect our values? How can we create a new relationship with time that prioritizes well-being over busyness? The way forward may lie in redefining our rituals and allowing ourselves the grace to slow down. Time is a precious resource, one that deserves our thoughtful consideration. When we think of time, we often envision it as a straight line, an unyielding flow from past to present to future. But delve into the realm of quantum mechanics, and that perception begins to shatter. In the microscopic world of particles, time does not hold the same rigid structure. Consider the phenomenon of quantum entanglement, famously described by Einstein as spooky action at a distance. Here, two particles can become intertwined, so the state of one instantly influences the state of another, regardless of distance. This challenges our notion of causality. If events are not solely bound by linear time, what does that mean for our understanding of reality? Furthermore, the concept of time in quantum mechanics is intertwined with uncertainty. Heisenberg's uncertainty principle suggests that we cannot know both the position and velocity of a particle with absolute precision. If time is to be measured, it can only be done probabilistically, leading to fascinating implications for the very fabric of the universe. A case study can be found in the works of physicist Carlo Rovelli, who posits that time is an emergent property rather than a fundamental one. His theory argues that time is a concept derived from the relationships between events, challenging the linear timeline we often accept. In Rovelli's view, the past, present, and future exist simultaneously, inviting us to reconsider how we perceive our existence. Exploring this idea further, researchers at the University of Cambridge are examining the role of time in quantum mechanics, suggesting that it may behave like a dimension we have yet to fully comprehend. With advancements in technology, we may uncover truths about time's nature that could alter the course of human understanding. How could these revelations redefine our relationship with time? As we stand on the precipice of quantum discovery, only the future holds the answers. Time and memory are deeply intertwined concepts that shape our identity as